In this short video, I would like to show you how Defender for IoT allows to analyze a firmware image. From the Defender for IoT portal, you can navigate the firmware inventory section where you can upload the firmware image. This feature is actually the result of the acquisition of Binwalk from the Refirm Labs, and Microsoft is starting to bring all its capabilities inside the Defender for IoT platform. So stay tuned, since there will be more to come. Click on Upload and select the compiled firmware image this way. Then enter a name for the vendor, a model, test, a version. I will use this. And then, if you would like, you can enter a description, so it will help you identify this firmware later on. I will use test firmware for demo purposes. Upload. Depending on the size of the image, the analysis will take some time to complete. Once the analysis is completed, you can click on the just uploaded image and get the first overview with the general information, like the firmware file size or the total extracted size, the number of files that has been extracted, etc. You can also see how much it took for this analysis, in this case just 17 seconds. And when you're ready, you can view the results. There are 3 tabs that you can navigate. The first tab shows a list of software components with their relative version and the license that is used. You can also see the location for each component in the file system. So you get kind of a bill of material, a software bill of material. Then you have the weaknesses page. This one is really useful. You can find all the CVEs found in the image, including critical ones, high, medium, and other severities. Clicking on a CVE, it will provide you with more information, including the affected component, a description of the vulnerability, and also quick links to reference pages with more information if you want to go deep dive. The last tab contains information on the binary. You probably already know that at compile time you can set certain flags for the hardening of your package. So in this section, for each module or executable, you can check these hardening configurations, such as whether it has been stripped of debugging information, whether the stack canary check is being used, or whether the module is a position independent executable. So the layout is randomized in memory, and this makes this binary stronger. Once you have all this information, you can be aware of the problems that your firmware is affected by, and if possible, you can ask your supplier to fix those problems, or you can put in place some countermeasures yourself.